In this section, we're going to look at solving logarithmic equations. When you're solving equations with logs, if you only have one log in the problem, you're going to use the definition to go to exponential form. Remember, if you have the log base A of x equaling y, that means the exact same thing as a to the y power equals x. So if you have a single log, you'll go to exponential form and you should be able to solve it from there. If you have two or more logs in the problems, you're going to have to use the properties. The first thing you're going to do is try to contract to a single log, because then if you can get it to a single log, you can use the fact that if you have the log of a number, you can go to exponential form and say that the base to the y power is going to equal x. If you have two or more logs equal to each other, we're going to use a new property, and that property looks like if you have the log base A of a number set equal to another log base A of a different number, then you can forget about the log parts and just set those two numbers equal to each other. This is very similar to the property we had if u to the x equals u to the y, then x has to equal y. This property is just saying if you have two logs set equal to each other and the bases match, you can forget about the logarithmic part and just set those numbers equal to each other. Let's go ahead and go to an example. Let's start off with the example of log base 2 of x is equal to -3. Notice we only have one log in the problem. Since we just have one log, we're going to use our definition here. We're going to go to exponential form, which will state that 2 to the -3 power equals x. At this point, 2 to the -3 we know is 1 over 2 to the 3rd power, or just 1 over 8 is going to equal x. Another example, if we have the natural log of x is equal to 1, if you only have one log, you're going to use your definition. You're going to go to exponential form that says e to the 1st power is equal to x. In this case, if you want a decimal solution, you're going to have 2.7182 is going to equal x. Now, these will get a little bit more difficult. Let's look at if we have the log of x plus the log of x plus 3 is equal to 1. Here we have more than one log in the problem, therefore we're going to have to use the properties. Remember the property that we had that says if we have log base A of m plus log base A of n, then that's going to contract back to a single logarithm of a product. That's going to tell us in this problem that we can go back to the log of x times x plus 3 is equal to 1. At this point, we only have one log in the problem. Therefore, we can go ahead and just use the definition and go to exponential form. Remember, the understood base, if it's not written with a log, is going to be 10. So we'll have 10 to the 1st power is going to equal x times x plus 3. At this point, you're back to an intermediate algebra problem. 10 is going to equal x squared plus 3x when we do the distributive property. Get everything to one side. So 0 is going to equal x squared plus 3x minus 10. Solve that problem. This one will solve by factoring into x plus 5 and x minus 2. Setting each piece equal to 0, x plus 5 equals 0, and x minus 2 equals 0. The two answers we're going to come up with is x equals -5 and x equals +2. At this point, it looks like we have two answers, but you need to remember what is the domain of logarithms. If we tried to put the -5 back into the original problem, we'd have the log of -5 plus the log of -5 plus 3 equals 1. Here we're taking the log of a negative number. You can never take the log of a negative number. That's not in the domain, so we have to throw out the -5 answer. If we put the 2 in to the original problem, we would have the log of 2 plus the log of 2 plus 3 is equal to 1. Notice now that the numbers we're taking the logarithms are positive, so our final answer here is just going to be x equals 2. We can look at another example. Let's look at the natural log of 6x minus 1 equals the natural log of 3 minus the natural log of x minus 3. If you count the logs we're starting off with in this problem, you'll notice we have 3 logs. Therefore, we're going to have to use the properties. The property that hopefully is coming into your mind because of this minus sign is that if we have the log of m minus the log of n, that contracts back to the log of m divided by n. So we're going to contract that right side back, and the right side is just going to be the natural log of 3 divided by x minus 3. At this point, we want to count the logs again. We still have 2 logs, therefore we're still going to have to use properties. Here we can use that new property that says if we have the log of one number set equal to the log of another number, we can forget about the log parts and just set those 2 numbers equal to each other. So that's going to tell us in this problem that 6x minus 1 is equal to 3 over x minus 3. Again, we're back down to an intermediate algebra problem. Multiply both sides by x minus 3. That will clear the fraction. Right side will just be 3. On the left side, we're going to have to use the distributive property and FOIL that out. X times 6x is 6x squared. X times -1 is -1x. -3 times 6x is -18x. And -3 times -1 is a positive 3. So that's going to clean up to 6x squared minus 19x plus 3 is equal to 3. Get everything to the same side so we can use the quadratic formula or factor, and that's going to give us 6x squared minus 19x will equal 0. Factor out the greatest common factor of an x. X times 6x minus 19 is equal to 0. Set each piece equal to 0, so x is going to equal 0, and 6x minus 19 is going to equal 0. This one's solved. For the second one, we're going to add 19 to both sides, so 6x will equal 19, and x will equal 19 over 6. Now we need to check those answers into the original domain. If we try to plug 0 in, 6 times 0 minus 1 is going to be a -1, which means we would be taking the log of a negative number. Even though the 0 is not negative, it makes our logarithm here negative, so we have to throw the 0 out. 19 over 6, we'll see if that works. We'll have 6 times 19 over 6 minus 1. That's going to be 19 minus 1, or 18. It works in the first logarithm. That's a positive number. In the last logarithm, if we have 19 over 6 minus 3, that's going to be 19 over 6 minus 18 over 6, which is going to be just 1/6, which is still positive. So 19 over 6 is going to be our only answer in that problem. Let's look at one final example. Let's look at if we have log base 3 of 2x minus 1 minus log base 3 of x minus 4, and set that equal to 2. We have 2 logs in the same problem, therefore we need to use the properties. The property that should be standing out to you because of that subtraction sign is the division property that says if we have the log of m divided by n, that is equal to the log of the top factor minus the log of the bottom factor. So we're going to contract back to a single log. We're going to have log base 3. The 2x minus 1 is going to be on the top. The x minus 4 is going to be on the bottom. And that's all going to be set equal to 2. At this point, we have a single log. Remember, when we have a single log, we're just going to use the definition. We're going to go to exponential form, and that will tell us that 3 to the second power is going to equal 2x minus 1 over x minus 4. Or 9 is going to equal 2x minus 1 over x minus 4. We're going to clear that fraction by multiplying both sides by x minus 4. That's going to give us 9x minus 36 when we use the distributive property on the left. On the right, it's going to cancel our fraction out to give us 2x minus 1, and we'll need to continue solving. Subtract 2x to get the x's to the same side. That's going to give us 7x minus 36 will equal negative 1. Adding 36 to both sides is going to give us 7x will equal 35. Therefore, we know that x has to equal 5 there. Checking 5 into our original problem to make sure we're taking the log of positive numbers. 2 times 5 minus 1 is going to be 9. It will check out there. 5 minus 4 is going to be 1. We'll have a positive log there. Therefore, x equals 5 is going to be our solution to that problem. Good luck on these homework